This is the geometry video for chapter 15, lesson 9. All right, so what have we already covered up until this point? Let's think about what we've already covered. We've covered what a plane is, how planes and lines are related, and where they intersect. We've talked about rectangular solids. We have talked about prisms, and with every prism, it has congruent bases, and its lateral faces are parallelograms. And we've talked about cones and pyramids, and they have apexes. So when we think of cones and pyramids, we're thinking 1/3 is the volume because of its apex. And we've talked about cylinders as well. Cylinders go pretty much together with prisms. Today, we are going to talk about other regular polyhedron. And in your book, you can see a picture on page 678 of the different polyhedron. We have a tetrahedron, which is four-sided. Tetra is actually, the root of it is a Greek word, and it means four. So tetra means four. A lot of times when you think about four, you think of a cube, but actually a tetrahedron has four sides and looks more like a triangular. Its faces look like triangles. We have an octahedron, which has 8 faces. Octa, means 8. We have a cube, which actually has 8 faces. And we have a dodecahedron, which has 12. You knew that dodeca meant 12. And now we have a new word, icosahedron. It has actually 20 faces. And so what makes for a regular polyhedron? You can look at the definition. It is actually convex, and it has all congruent regular polygons as its faces. And it has an equal number, the exact same number of polygons that meet at each vertices. So like in the tetrahedron, there are 3 faces that meet at each vertex. In the icosahedron, the octahedron, there are 4 faces that meet. In the icosahedron, we have 5 faces that meet at each vertex. And so as you're completing your homework, you're going to need to know a formula that is not in your book. And it's Euler's formula, which I call him Euler. But it's Euler's formula for all polyhedrons. And it says that the number of vertices plus the number of faces minus the number of edges in any polyhedron is always going to equal 2. So if we take a tetrahedron, let's just take a tetrahedron. All right, we know that its vertices, if you can look here, it has 4 vertices. 1, 2, 3, 4. All right, so we're going to write 4 for our vertices. We know it has 4 faces, tetra meaning 4 faces. And then its edges, if we look at its edges, so it has 1 here, 1, 2, 3 in the lateral, and then 3 where it intersects with the base. So there's 6 actual edges. And that does, in fact, equal 2. That formula holds true for every polyhedron. All right, there's another formula that goes along with this. And it says, here's what it looks like. SF equals 2 times E. And actually stands for the number of sides per face. And of course, F is the number of faces, E is the edges. So if we go back to the tetrahedron, the number of sides per face is 3. So 3 sides per face times the number of faces, which is 4, thus the word tetra, equals 2, and we already said it has 6 edges. So this formula will always as well hold true. So S being the number of sides per face, F being the number of faces, E being the number of edges. And then this formula you will need to know, not only for your homework, but also for the test. All right, so now looking at what we need to know for the test. All right, here is, I'm trying to block the blazing light here. For chapter 15, I'm just going to let you see my little sheet here, and I'll go over it. So you can actually stop the video if you'd like. So you have to understand what skew lines is and the definition on page 619. Remember, skew lines are 2 lines that do not lie on the same plane, yet they are neither parallel nor do they intersect. You need to know the definition of a regular polyhedron on page 618. I'm sorry, 678, if I could read. You'll need to know all the formulas, really. So you will also probably need to remember how to calculate the area of a regular polygon, because the base of a prism could be any regular polygon. So you'll have to remember Mr. Squared from the previous chapter. You'll need to be able to recognize the shape of a cross section, which is where we looked at Cavalieri's principle, and that's on page 641. You'll need to know the definition of a prism and what the lateral faces are, what the bases are. You'll have to be able to recognize the bases. So remember, in a prism, the bases are congruent. And so you have to be able to see what the bases are. You'll need to know postulates 11 and 12 on page 619 and be able to calculate surface area, lateral surface area, and volume for every shape that we have talked about in this lesson. And you'll have to remember about ratios of similar solids. So if I'm talking perimeter or length of a side, their ratios are going to be the same. If I'm trying to find, it's just going to be raised to the first power. But if I want to go from area of one polygon to an area of a similar polygon, then my ratio is going to be squared. And volume, it is 3-dimensional. So your volume ratio is going to be cubed. And you'll need to know, of course, the formulas that I just gave you, Euler's formulas. And that is actually used on review question number 60. And I also believe it's used in lesson 9 as well. All right. I hope this helps. I'll talk to you guys soon.